Hello, welcome back again. This is Quifitech Lab channel. We are still on the same topic of failover redundancy protocol. In this lab, we will be configuring visual router redundancy protocol. So what we have on screen currently, we have three routers. They are directly connected to this internet over there, and they are also directly connected to layer 2 switch. Now this switch itself is connected to two end host devices. Okay, and then we will be using these IP addresses to these interfaces gigabit 0/1 on router 1, and on router 2 we're gonna assign the IP address on gigabit 0/1 also, and also on router 3 we're gonna assign this IP address on that interface itself. Okay, so on our recent video, if you haven't watched it, you can go back and watch it, which actually deals or based on how to configure the HSRP, okay, which is a Cisco proprietary protocol. And this time around we are configuring a VRRP, which is an open standard that can be configured on any vendor or any device such as MikroTik routers. So in these routers that we have currently, we will be demonstrating using Cisco routers, and then on an upcoming video we will actually dive into the open standard or any other routers that we can use to demonstrate this VRRP. Okay, so let's assign the IP addresses before we actually talk about this VRRP. So we're just gonna assign the IP addresses on these interfaces, which is gigabit 0/1 on that router over there, and this router and that router. Okay, we're gonna try as much as we can to allow this router to break out to the internet, and then from there we can then configure this VRRP. Okay, remember we're still gonna be utilizing um, the visual router and assign it the IP address as we've been doing on an HSRP. Okay, let's do it now. Let's go to the router over there and start our configuration. Okay, so let's give it some time. Okay, here we are. I'm just gonna navigate to global config mode by typing the command config terminal. Alright, first thing first, I'm just gonna change the host name so that we will see which router we're currently configuring. I'll just call this one R1. This is the router that we're trying to make it as our master. Remember, on VRRP we can have a number of routers, and then one of those routers will be the master and the rest of the routers will be our backups. Same thing that was applying on HSRP. It's the same concept, it's just that this time around we will have this master which will forward the traffic to the internet, and then the remaining routers will act as the backup, so that once the router goes down, these gateway they will take the role of being a master too. Okay, so let's just select the interface that we want to assign the IP address into, gigabit 0/1, and then let's assign the IP address 20.20.20.2, 255.255.255.0, and then let's say no shutdown. One of the most important configurations when we dealing with VRRP or HSRP, on the interface where we actually gonna be running our VRRP, we need to ensure that that interface is assigned with or configured with an IP address. Okay, so this interface have the IP address right now. All we have to do, we have to go back to the other interface on this router, which is gigabit 0/0. I'm just gonna select that interface, gigabit 0/0, and then I will assign the IP address dynamically by typing the command IP address DHCP, and then I'm just gonna type no shutdown. I will wait for the interface to come up, and then we will get the IP address from the router that is providing the IP address from on the other side. Okay, Let's give it some time, and then it's gonna give us the IP address that belongs to this range 192.168.88. Okay, as you can see, we have that IP address that is available on the pool, and then we can save our configuration now. Let's say do show IP interface brief to ensure that all of our interface they are assigned with correct IP addresses. As you can see, we have that interface which is gigabit 0/0 assigned dynamically with that IP address 192.168.88.229. Okay, now let's minimize this and move to the second router in the middle. So that router over there is router, this is the router. Okay, this is router 2, so we're gonna give it a name of router 2. I'm just gonna enable this router and type the command config terminal. From here I can configure the host name as well, and then I'll type the command hostname R2. From here same thing applies. I just need to select the interface that I want to assign the IP addresses to. In this case we're gonna start by gigabit 0/1. This is the interface that we're willing to assign the IP address to. We'll type the command IP at 20.20.20.20.1. Okay, 20.20.20.1. Subnet mask of class C IP address, and we're trying to hook this interface to ensure that when we run that VRRP, that interface is up. Okay, as you can see, the status has changed from down to up. Now we have to select the other interface on this router, which is gigabit 0/0, and then all we have to do is to do the same thing, assign the IP address dynamically by typing the command IP add or IP address DHCP, and then we need to ensure that the interface is up, and let's give it some time. The router on the other end will issue, or it will leave us with an available IP address on the pool. Okay, let's give it some time. As you can see, we have got the IP address given to ourselves. We have 192.168.88.227, which also belongs to that range. Now let's move quickly to this router over here. Okay, let's move quickly to this router over here. On this router we still gonna do the same thing by typing the command config terminal to navigate to global config mode. Once we're here, we can then change the host name to R3, and we have to select the interface that we're willing to configure or assign the IP address to. In this case, this is the interface that we currently talk about, so I'm just gonna select the interface and type interface gigabit 0/1, and we're gonna assign the IP address of 20.20.20.3. The subnet mask is going to be 255.255.255.0. We have to ensure that the interface is up by typing the command no shutdown. Let's give it some time. The interface will then come up, which will change its state from down to up. Okay, now we need to do the same thing on the other interface, which is interface gigabit 0/0. I will just quickly assign the IP address dynamically by typing the command IP add DHCP. Again, we need to ensure that the interface is up by typing that command no shutdown. Okay, let's give it some time so that the router that we are directly connected to will lease us, or that it will give us the IP address that is available on its pool. Okay, as we can see, we have that IP address. Now what does that mean? It means that these routers or these interface, they can be able to communicate because they are directly connected via the switch. Okay, so if I can try to ping the IP address that was assigned on that interface itself, I can be able to ping this one also. I can be able to ping this one also. Let's verify that. So let's go back and double check what's the IP address that was given to this router over there. 227. Okay, 227 is the IP address that was assigned on this interface on this router over here. So if we run the command do ping, this is gonna allow us, this is a tool that's gonna allow us to send an ICMP messages or echo request to that interface. Let's say do ping 192.168.88.227. so we are expecting to get the ping successfully when we're trying to ping that interface, because as we said, these interface, they have the IP address that belong to the same network, so therefore they can be able to ping each other. Okay, one thing that we can try to do is to try and ping to the internet. Let's try from this router over here, which is router 3. Let's see if we can be able to ping to the internet. Do ping 8.8.8. we should be able to ping to the internet also from that router. However, when we try to ping from this interface itself, we should not be able to ping to the internet. Let's verify that by typing the command do ping 8.8.8. this is a Google DNS, and then this time around we need to specify the source where we're actually trying to ping from. In this case, we're trying to ping from this interface itself, gigabit 0/1, and then let's press enter and find out. As you can see, our packet that we're trying to send to the internet, they are actually being dropped. Okay, although we can ping from the router itself using gigabit 0/0, we can be able to access the internet. However, if we try to ping from this interface, we cannot access the internet. In this case, we need to configure something called access list, and whenever you have issues with the router failing to go to the internet, you need to ensure that the net rules are enabled correctly, and also the access list to permit the traffic from local area network to outside is actually enabled. Okay, so let's start by maybe including the feature of the OSPF in this lab. So let's try to create some sort of dynamic routing protocol, router OSPF. Let's give us the process ID of 10, and then let's set up the router ID of this and call it 3.3.3.3. okay, and then let's just include the network of 20.20.20.0, and then we need to specify the wildcard mask. Remember, it's only OSPF in the access list that utilizes the wildcard mask, and then we need to specify the area. Let's assume that the whole area is belonging to area 0, which is a backbone. Okay, now let's exit. We're gonna run the same configuration, or let's just finish up by configuring the access list. All we have to do is we have to type the command access list. We have to specify the command access list 1, and then we need to specify permit any traffic. We need to permit everything. In this case, this is just a demonstrational purpose. Of course, you can permit based on any IP address that you want to permit or you want to deny, or based on any port that you want to permit or deny. In this case, we just want to allow everything. So now all we have to do is to also configure something called NAT, network address translation. In this case, I'm just gonna type in the command IPNet inside, and then I will specify the source list that I used on that access list, and then I will specify the interface that I want to overload. In this case, I want to specify gigabit 0/0. This is the interface that I want to overload. Okay, and then let's go back to the global config mode, and this time around I need to specify which interface is our inside and outside. So let me select the interface first. Interface gigabit 0/0, IPNet outside, because this is the outside interface. Okay, so let's give it some time, and then once done, and then we're gonna come back to this interface and specify it as the interface or as the IPNet inside. Okay, let's go to this router over there and do the same configuration. Let's go to this router over here, and then let's do the same configuration, and this time I'll feature the OSPF again with the same process ID of 10, and then I need to specify 2.2.2 as my process ID, and I need to specify the network which is 20.20.20.0 with that subnet mask which we convert into a wildcard mask, and then I have to specify the area which is area 0, and then I'll exit. So I can just simply see that now we have adjacency forming in here between these two routers. Remember, we have the OSPF instance running on that router, and also on this router we have the OSPF running. Now we have to configure the access list, and then we're going to use the same group number, and then from here we're just going to permit everything, permit any, and then from here all we have to do is we have to type the command IPNet inside source list, and then we're gonna use that access list number that we have configured on the access list, and then we have to specify or select the interface that we actually willing to overload, which is gigabit 0/0, and then let's specify the command overload. Okay, all we have to do now is to select the interface, which is interface gigabit 0/0, and we have to type the command IPNet outside. Okay, let's give it some time. Now let's go back to this router, which is router 3, and select the interface that we didn't configure with IP NAT inside. Now from here we should be able to ping to the internet by typing the command 8.8, but from this source itself, gigabit 0/1, we should be able to ping. As you can see, we have successfully able to ping from that interface towards the internet. Okay, which means now if we configure this device over here, it can be able to break out to the internet. Alright, now let's go back to router 1. I'm just gonna try to move this to the left hand side, to the right hand side, and then let's go back to router 1 and try to configure the OSPF also in there. Okay, first thing I want to do is to enable this router, and then navigate to global config mode by typing the command config terminal. The hostname is already there. All we have to do now is to create the instance of OSPF 10, and then let's give it the router ID of 1.1.1.1 because we're not using any loopback interface for now. All we have to do is to specify or advertise the network, which is 20.20.20.0, and we need to specify the wildcard mask. This is area 0, which is our backbone, and then I'm just gonna exit. All I have to do again, we need to create some sort of an access list. As you can see, we have adjacency forming, so all of these routers, they have formed the adjacency, so they can be able to connect, or they can be able to ping each other. So let's create the access list, access list 1. We want to permit any, and then let's create the network address translation, which is actually a pet. So IPNet, utilizing that source list, IPNet inside source list 1 interface gigabit 0/0. Okay, so now we have to specify that IP net. Oh, we need to select the interface. Sorry, we need to select the interface, which is gigabit 0/0 IP net outside. Sorry. Now let's give it some time, and then we're gonna come back to it. Let's go back to router 2. On router 2, we need to ensure that the interface gigabit 0/1 is enabled with IPNet inside as well, so that it will be able to ping successfully to the internet. Do ping 8.8.8.8 from a specific source of gigabit 0/1. As you can see, we have sent 5 and we have received 5, so all of the packet we sent was received. We have been able to reach to the internet from that specific interface on router 2. Okay, I'm just gonna minimize this. On router 2, we have been able to reach out to the internet. Let's give it some time. Okay, there we are. Let's select that interface again on this router and verify our command. Interface gigabit 0/1 IPNet inside, exit, do a ping 8.8.8.8 towards the internet using that source, which is gigabit 0/1. Okay, as you can see, we can also be able to send those ICMP echo requests, and then we got the replies. Right, so we have successfully configured the routing part on these routers, so we can be able to connect to the internet. Now let's talk about VRRP, Visual Router Redundancy Protocol. Okay, again, this is a redundancy protocol which allows us, or which allows the client computers to be able to connect to the internet utilizing multiple gateways. Okay, so the client computers will only know the IP address of the visual router, however not specifically the interfaces configured on the routers themselves. Okay, so if one gateway goes down, it will utilize the gateway of the VRRP. Okay, the IP, it will utilize the IP address of the VRRP. In this case, this is gonna be our master, and this is gonna be our backup. Right, so on VRRP we have a number of groups that we have. I'm just gonna show you now. The configuration is actually different from, it varies depending on the router model that we're using. In this case, we are not using Nexus switches, so we're just gonna run the command VRRP, and then we need to specify the IP address of that VRRP. In this case, we need to select the interface where we'll be running our VRRP. In this case, this is the interface that we're aiming for, gigabit 0/1. All we have to do is to type the command VRRP, and then we need to select the group, but I want to show us how many groups that we can choose up to. We can make up to 255 groups. Why would we use multiple groups on the same lab? Suppose we want to do something called load sharing or load balancing, right? So if we want to ensure that our packet is distributed equally amongst our routers, we can configure multiple groups where this router itself, on group 1 or on any group, it can be a master, and on another group it can be a backup on its own, and on this router itself it can be a master and it can be a backup on its own. Alright, so suppose, as you can see, this is a master. Let's say on group 1 this is a master and this is a backup on group 1, but on group 2 this could be a backup while this one is a master on group 2. Alright, now let's come to the group that we want to utilize. Let's use group 1, and then we just need to specify the VRRP IP address, which is 20.20.20. Let's utilize different number. Maybe let's change it to 10. Okay, we're just gonna use 10. Okay, as you can see, the state have been changed from what to a master. Okay, this router is actually a master right now, and remember, we still need to configure something called a priority. And this time around on VRRP, unlike the HSRP, the preemption is enabled here. On HSRP by default the preemption is disabled, so you will have to enable the preemption. In this case on VRRP the preemption is actually enabled by default. Alright, so again the highest priority wins, and also the highest IP address wins. If all of the routers they all have same value of the priority, then the one that have the highest IP address, it will become a master, and the remaining routers they will be the backup routers. Okay, because we want to ensure that this router is what, it's a master, so we need to configure the priority and send it to be a higher priority value. Okay, so how do we do that? We need to specify the priority value by typing the command VRRP group number and set the priority, and let's make it okay. Before we actually point the number, let's check also up to which number that we can use. The priority value here we can use up to 254, not actually 255, so we need to use the highest priority value as we can to ensure that this router remains a master no matter what. Okay, so let's just save that configuration, and then let's find out about something also. Authentication, VRRP 1 authentication. You will notice that here we can also use MD5 and also the plain text. I'm not just gonna configure this for now, let's leave it, and then let's go to this router over here. Let's give it some time. Okay, remember we're trying to run the VRRP on the interface gigabit 0/1. This is the interface, and then from this interface we need to specify VRRP number, and then this is a group number, so it supports multi-groups. VRRP support multi-groups, and this is the group number 1. Okay, and we need to specify the visual IP address, which is 20.20.20.10. Let's give it some time. You will see that this router will become a backup. Why? Because it have the default priority set on it, and that priority itself is lower than 254, which is set on the master router. Okay, so let's also configure. Okay, I'm just gonna exit. Let's go back and ensure that interface is actually up, no shut down. Right, now let's go back to R3. This is R3. Let's give it some time. Okay, let's enable this router config terminal. Let's select the interface gigabit 0/1 VRRP 1. We are putting all of these into the same group for now because we are configuring redundancy. We're still gonna be able to show how to configure VRRP load sharing based on the groups. Okay, let's say VRRP1 IP 20.20.20.10, and then as you can see we have backup. So if I type the command to show VRRP, you will be able to see that the priority is on default, and by default the preemption is enabled. We didn't type no command that says preemption, so by default this is enabled, unlike HSRP. In HSRP by default the preemption is not enabled, you have to enable it. And then we have this state of this router, it says it's a backup. Okay, so if you pay attention also, the visual MAC address of this one is actually different than the visual MAC address of HSRP version 1 and also for version 2. Right, so we have the master router here. It tells us that we have 20.20.20.1 as our master, and then the priority is set to 254. Right, now let's go to the other router also. Let's go to the other router and find out what's going on. Do show IP interface brief. Okay, now let's do show VRRP. Okay, let's see, we have this router also as a master, so it tells us that this router is a master. It have the 20.20.20.1. so this is the this is the priority that we set on this router. Actually we're trying to configure it on that router, however we were configuring this router, so this router have this priority of 254. Okay, and this is the master. Now let's see what happened on this router over here. Because it is impossible to have two masters at the same time. One must be a master and the other one must be backups. We might have configured the wrong router, so let's verify. Enable config terminal, do show VRRP. As you can see, we have no VRRP running on this interface. So let's select the interface gigabit 0/1, and then we're just gonna say VRRP 1 IP 20.20.20.10. so this will become a backup also, because we now have the master that we have configured on this router over there. I'm just gonna swipe this around to make it simple. Okay, so we have successfully configured the VRRP, and then let's verify in here. We're expecting to see that this router will also tell us the information about itself and also about who is the master. Okay, do show VRRP. So as you can see, this router tells us that it is a backup and it have the priority value set to 100, its default priority, and then it have the preemption enabled by default, and it shows us that we have a master router which is 20.20.20.20.1, okay, which have the priority of 254. Alright, so we can also do interface tracking and object tracking on VRRP, just like we have done it on an HSRP. Okay, so suppose that we actually want to ensure that this router remain as our our master, and we want to actually to ensure that the other router become a master as soon as this interface or this link from gigabit 0/1 to the internet is actually broken somehow. We want to detect that if this link goes down, then we need to decrement the value of the priority from 254 to a lowest priority below 100, so that the other router between this backup and that backup, it will take a role of being what? A master. Obviously this will become a master if we track that interface to have a value of 99. This will become a master. Why? Because the default priority is 100 in both of these routers. However, when we check the IP address, this have the highest IP address, so it would be the one that takes the role of being a master. But let's find out. We're just gonna run the tracking on this interface gigabit 0/0, and then we're gonna decrement the value as that interface is being shut down, so that this router will become a master, or any of the routers in the network will take a role of being a master once that link is broken down. Okay, let's find out by coming to this router itself, which is a master. Okay, let's give it some time. So we are willing to enable this tracking on a global config mode. We want to track some sort of an object, which is, let's call it object 1, and then let's say this is the interface, and then we need to select what is called line protocol. So let's come in here. We need to specify that gigabit 0/0. We need to track the line protocol of this. Okay, so I'm just gonna exit and then select the interface itself, gigabit 0/1, and then from here I need to specify VRRP 1 track object 1 decrement value by, now let's count from 254 to 99. Okay, let's say we actually willing to decrement by let's say we want to decrement by 155, or maybe by 157. Okay, so as soon as that interface is being shut down, we willing to observe the state changes from being a master to a backup, and then we also expect to see these routers, one of these routers, it will take a role of being a master, so it will change state from backup initially. After we find that this interface is down, any of these routers will take a role of being a master. So we're expecting to see this router itself as a master. Why? Because we know that the election is actually based on what? Based on the priority. Priority matters. But now what if we have the same value of priorities? Then we will have to look into the router that have assigned with the IP address which is higher than the other ones. In this case we have 20.20.20.3, and we have 20.20.2 20.2, which means that this is the router that will be elected as what, as the master. Okay, let's find out though. I'm just gonna exit in here, and then I will shut down that interface. But before I shut it down, let me try to bring this up so that we will see the status as we actually bring that interface up, and we're gonna also see how long does it take to change over or to fail over. Okay, because this is a redundancy mechanism where we're trying to see the failover actually happening between multiple gateways when one goes down, and then the other one must be forwarding. Okay, so I have visibility of all of these routers right now, so we will see all of them. They will try to change their status as we shut down that interface over there. Now let's shut down the interface. Remember, this is R3, which is this one, which have a high priority, and then this is R1, and then we are running the command on R2. Now let's shut down that interface. Gigabit 0/0 shut down. Okay, now let's see what's gonna happen. Let's give it some time and observe exactly what's gonna happen. We're expecting to see that the interface is down. Obviously, the adjacency between the OSPF neighborship, it will break. Okay, on specifically on that interface, or it won't break because it's the interface that is facing the internet. Okay, so remember, we have said that this router, we're expecting to see it take the role of being what, of being a master. I'm just gonna show you right now by typing the command do show VRRP. As you can see, this router has become a master. Why? Because of this IP address that it has. It have 20.20.20.20.3. It has the highest IP address, even though if we, as you can see, this one, this is R1, which took the role of being a backup. Even though do show VRRP, even though they have the same priority value, as you can see, these routers, they have the same priority value. However, because the IP address of this one is actually less, so this router is actually a backup router, and this is the router that is a master. This is the router that is a master. As you can see, the status is just like that. If you pay attention, the visual MAC address is still the same because it's of the same interface. Right, now let's go in here and see what do we have. Do show VRRP. Because of that interface, which is gigabit 0/0, which is faces the internet, it is down. So now what we're gonna have is, we don't want to forward the packet towards that path. Instead, we want to forward it towards the different router to the internet, because we know exactly that there is a break somehow between that router towards the internet. Okay, from that interface towards the internet. Now let's see what's gonna happen if we try to hook the interface up again. Because of preemption enabled, that router initially will take its role back. Okay, because of the priority also set on the router, which is very high, it is 254. So we are expecting to see that router regain its state to show VRRP. As you can see, this router itself has regained state to being what, a master. Alright, the other routers, they have regained their state also of being what, to show VRRP, of being backups. Right, let's run it this time around. Also in here, do show VRRP. Okay, As you can see, this has changed its state to what? To being a backup. Okay, so we actually have been successfully configured this VRRP. This is of course a basic lab where we touched upon this. Okay, but the concept is the same. Now on an upcoming video we will try to demonstrate using macrotic router board, and then so that we will see exactly how this relates with its open standardization. So because this is an open standard, so which means you can configure this VRRP on any vendor. You can configure it from Macrotik, Fortinet, and any other vendors. So HSRP is Cisco proprietary, which means you can only configure it on Cisco routers. Alright, let's meet again on an upcoming video. Okay, bye.